Hi, this is Miss T. Today I'm going to be talking to you about isotopes. First, we need to talk about shorthand notation. Scientists needed an easy way to keep track of an element's basic properties. So you can see on your screen, this is a generic way to set up a shorthand notation. You should notice the X, and this is the main focus of shorthand notation. The X is going to represent an actual element. For example, if we were to pick phosphorus, we would use the element's symbol, P, in replace of that X. The A also represents something. The A is going to be the element's mass. Remember, in class, and also in the previous video, we learned that mass is equal to the element's protons plus their neutrons. The Z in shorthand notation represents an element's atomic number. Again, in class, in the last video, we learned that the atomic number is equal to the number of protons. So again, the X is the symbol, the A, the top number, is equal to the mass, or protons plus neutrons, and the Z, the bottom number, is equal to the number of protons, also known as the element's atomic number. Here's an example. Helium's element symbol is He. Its mass is 4, and its atomic number is 2. Looking at this, we know that helium has a mass of 4, and also that the mass is made up of protons and neutrons. The atomic number is 2. We see that on the screen as well, and we also know that 2 represents how many protons an element has. Take a look at the sodium. It has an atomic number of 11, an atomic mass of 22.990. When we do a shorthand notation, it's difficult if you use decimal points, so let's go ahead and round that 22.990 up to 23. When we do the shorthand notation, we do the Na as the element symbol, and then the top number is going to be 23. Again, remember that represents our mass. The bottom number represents the element number, which is 11, and also represents the number of protons. So again, top number is 23, which is the mass. Bottom number is 11, which is the element number, which is equal to its protons. You may take a look at this and notice that you could do some math here. If you look at 23 and know in your head that that is protons plus neutrons and that the bottom is protons, maybe you think that you could subtract the two from each other. So for example, when you subtract 23 from 11, you get 12. So in fact, this element has 11 protons, but it has 12 neutrons. So in order to get an element's neutrons, you can subtract its mass from its atomic number. To summarize, the top number represents the atom's mass. Again, remember, protons and neutrons make up the mass of an atom. The bottom number represents the number of protons of the specified atom. And you can find out how many neutrons an atom has by subtracting the two numbers. Hopefully you're thinking, but wait, we learned in class that sodium should have 11 protons and 11 neutrons. You're right. That's where isotopes come in. Isotopes are elements that have the same number of protons, but they have different numbers of neutrons. The mass number that we are provided is the average mass of all of the isotopes of that atom. So you may have an atom of sodium that has 11 neutrons, or you may have an atom of sodium that has 12 neutrons. Those are both isotopes of each other. Remember that isotopes of each other are always going to be the same element. They will always have the same number of protons, and they will always have the same element number. Take a look at this picture. In this picture, we see two atoms. The atom on the left has 2 positive protons represented by the 2 yellow spheres. The atom on the right also has 2 positive protons. Both of these atoms are helium. However, the atom on the left only has 1 red isotope, or excuse me, one red neutron, while the element on the right has two red neutrons. So these both are helium atoms. However, the one on the left has one neutron and the one on the right has two neutrons. We still consider these both helium. Take a look at these oxygen isotopes. On the left, we have 8 protons, and on the right, we have 8 protons. They are isotopes of each other because they both are oxygen. However, the element on the left has 8 neutrons, and the element on the right has 10 neutrons. So remember, isotopes are elements that have the same number of protons but different number of neutrons.